Here's a fact that should keep you awake at night. There's currently an object in our solar system with a 1 in 10,000 probability of occurring naturally. Yet, here it is, defying the laws of physics as we understand them. 3IATLAS has been observed by multiple observatories worldwide, and every single one confirms the same impossible reality. This thing has a tail that acts more like rocket exhaust than cosmic dust. In the next few minutes, we're going to break down exactly why NASA's own data suggests this might not be a natural object at all, and what that could mean for humanity's future. On the night of July 1st, 2025, astronomers scanning the skies picked up something extraordinary. At first, it looked like just another faint streak of light against the background stars. But within hours of tracking, it became clear this was no ordinary visitor. The object was moving at nearly 130,000 miles per hour. That's faster than anything bound to the sun could travel. For comparison, Earth orbits at just under 70,000 miles per hour. This thing was moving almost twice that speed, cutting through the solar system like a bullet. As data poured in, scientists realized its orbital eccentricity was greater than 6. To put that into perspective, any eccentricity above 1 means the object is not bound to the sun at all. It isn't looping back. It isn't returning. It's on a one-way journey. A true interstellar traveler. This placed the object in an incredibly rare category. Only 2 others in history have ever been observed crossing through our solar system from the stars beyond. The first was in 2017, the mysterious Oumuamua, which sparked endless debates about its shape, its acceleration, and even its possible artificial nature. The second was Comet Borisov in 2019, which behaved much more like a typical comet. And now, in 2025, we have the third, catalogued as 3IATLAS, a new interstellar interloper. But unlike its predecessors, 3IATLAS would quickly reveal itself to be even stranger, even harder to explain, and far more unsettling. From the moment it was first tracked, scientists knew they were dealing with something unprecedented. Its speed alone was shocking. At nearly 60 kilometers per second, it was traveling fast enough to cover the distance from Earth to the Moon in just over an hour. That's cosmic lightning. But beyond speed, there was something else that made astronomers sit up straight. Its trajectory. 3IATLAS wasn't coming in from some random angle across the galaxy, like most interstellar debris should. Instead, it entered our solar system on a path nearly aligned with Earth's orbital plane, within just a few degrees of the ecliptic. The odds of such a perfect alignment happening by chance are vanishingly small. In the weeks following its detection, telescopes around the world began locking on to this strange object. And the deeper they looked, the more unsettling the picture became. What at first seemed like a faint comet soon began breaking every rule astronomers thought they understood. Atlas wasn't just another rock from deep space. It was something altogether different. Something that defied the patterns of nature we've come to expect. And as the days ticked by, it became clear. This was the start of one of the greatest astronomical mysteries of our time. When most people imagine a comet, the picture is clear. A glowing head trailing a sweeping tail of gas and dust, pushed outward and away from the sun by solar radiation, and the constant stream of charged particles we call the solar wind. This is a universal rule. No matter where a comet comes from, no matter what its size or composition, its tail always points away from the sun. That's basic physics. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. But 3IATLAS refused to play by the rules. When telescopes zeroed in on the object, astronomers were stunned to see something no one had ever witnessed before. Its plume, its so-called tail, was not streaming outward into the darkness. Instead, it was pointing directly back toward the sun. Think about that for a moment. Against the powerful force of solar radiation, against the relentless push of the solar wind, this object seemed to be doing the impossible. Its material wasn't being blown away. It was flowing inward, in the exact opposite direction, and it wasn't just a faint anomaly that could be brushed off as an error in observation. The plume was narrow, sharply defined, and completely stable. Night after night, as different observatories turned their instruments toward 3I₄ATLAS, the same result appeared: a jet that looked nothing like a comet's tail, and everything like something else entirely. Comet tails are diffuse. They spread out. They shimmer and shift under the sun's energy. But this was different. 3I₄ATLAS's plume held its shape with remarkable precision, more like a beam than a cloud. Instead of dispersing into space, it cut a clear, straight line, as if directed, as if controlled. For many astronomers, the implications were disturbing. Nature doesn't usually draw such clean lines. If this was truly a natural comet, it was breaking every known pattern. And if it wasn't natural, then what exactly were we looking at? The discovery of the sunward plume marked a turning point. It was the first undeniable sign that 3I₄ATLAS wasn't going to fit neatly into any existing category. The object wasn't behaving like Borisov, the icy interstellar comet of 2019, nor was it mimicking Oumuamua, which showed no tail at all but still managed to accelerate mysteriously. Instead, 3I₄ATLAS was carving out its own mystery, one that challenged the very foundation of how scientists understood comets. At this stage, the questions began piling up faster than the answers. What kind of physics could drive a plume against the sun's energy? What force could generate such a focused, consistent jet? Was it simply an exotic chemical reaction, or could it be something far more deliberate? As days passed, what had seemed like a curiosity was quickly becoming a crisis for comet science. And the closer astronomers looked, the stranger it became. When an observation challenges the foundations of science, the first response is always skepticism. Could this sunward plume be an error? A trick of the telescope? A glitch in the processing software? To test it, astronomers around the globe turned their most powerful eyes to the sky. The Hubble Space Telescope was among the first to lock onto 3I₄ATLAS. Floating high above Earth's atmosphere, Hubble has given us some of the clearest images of comets in history. And when its instruments recorded the plume, there was no mistaking it. The tail was there, narrow, defined, pointing in the wrong direction. Next came Gemini South, perched on a mountain peak in Chile, one of the finest ground-based observatories on the planet. Its massive mirror confirmed the same sight. No matter how carefully they checked their equipment, the data was undeniable. The jet of 3I₄ATLAS was flowing inward, back toward the sun. Then came a third confirmation, from the Lowell Observatory in Arizona, a historic facility that has watched the skies for over a century. Once again, the results were identical. The plume was real. 3 different instruments, 3 different locations, weeks apart, and every single one told the same story. Even more unsettling, the plume wasn't fading, shifting, or breaking apart the way a normal comet tail would. It persisted. Night after night, week after week, the narrow jet held steady. It didn't disperse into a broad fan of dust. It didn't curve under the pressure of solar radiation. It behaved like a controlled stream, aimed with precision, utterly unlike any natural plume ever recorded. For the scientific community, this was the moment when doubt began to turn into unease. A single observation can always be dismissed, but when multiple world-class observatories, each using different instruments and techniques, all confirm the same impossible phenomenon, it becomes something else. A pattern, a mystery that refuses to go away. By this point, the whispers began. Could this object be something other than a comet? Could it be a machine? A probe? Some kind of interstellar technology that uses directed exhaust to steer its course? The official explanations tried to keep things grounded. Perhaps it was a chemical plume, produced by some exotic volatile that reacted strangely under the sun's heat. Perhaps. But the longer the plume persisted, the less convincing those answers became. Because comets don't hold steady like this. Nature doesn't fire clean beams into space. And yet, 3I₄ATLAS did. The confirmation from Hubble, Gemini, and Lowell left astronomers with no escape. This was real. It was happening. And whatever 3I₄Atlas was, it wasn't going to fit neatly into any natural category we'd seen before. Once the plume was confirmed as real, the next question became obvious. What exactly is it made of? For that answer, astronomers turned to the most advanced tool available, the James Webb Space Telescope. Webb's powerful spectrographs can break down the faint light reflected and emitted by objects in space, separating it into a chemical fingerprint. From that fingerprint, scientists can tell which molecules are present and in what amounts. When Webb analyzed the light from 3I₄Atlas, the results stunned researchers. The ratio of carbon dioxide to water was unlike anything ever seen before. In ordinary comets, the ratio might be 1:1, sometimes lower. But here, the numbers were extreme. Nearly 8 parts carbon dioxide for every 1 part water. This was a chemical imbalance that didn't match anything we've studied within our solar system. No comet from the Oort cloud, no asteroid fragment, no icy body from the Kuiper belt has ever shown such an overwhelming dominance of carbon dioxide. But that wasn't all. The analysis also revealed something even stranger. Nickel was present in the spectrum, a metal found in many cosmic bodies, but iron was missing. On Earth and throughout the solar system, nickel and iron almost always appear together. They form in the same processes, locked side by side in meteorites, asteroids, and planetary cores. To find one without the other is deeply unusual, almost unnatural, together. These findings painted a picture of a body whose composition doesn't resemble anything we've ever cataloged in our cosmic neighborhood. It wasn't just an odd comet. It wasn't just an icy fragment with peculiar chemistry. It was something entirely different, as though it had been forged under conditions far outside what the solar system could produce. For some scientists, the results sparked speculation that 3I₄Atlas could have formed in an exotic stellar nursery, a place with chemical balances completely unlike our own. For others, the anomalies raised a more unsettling thought. Could these chemical signatures be the byproduct of technology, of processes not entirely natural? Because here's the puzzle. Comets vent material in chaotic plumes, a messy mix of gases and dust. But 3I₄Atlas was releasing a controlled, narrow jet, one dominated by carbon dioxide, reinforced by nickel, and conspicuously lacking iron. It's the kind of imbalance you might expect if someone was selecting materials for a purpose. By now, the mystery was growing darker. First came the impossible plume. Then came the confirmation that it wasn't an illusion. And now, the chemical fingerprint revealed that 3I₄Atlas was no ordinary traveler. Whatever it was, it didn't come from anywhere we know. As astronomers traced the path of 3I₄Atlas through the solar system, the story became even stranger. Not only was its speed extraordinary and its chemistry alien, but its trajectory defied the odds in ways that set off alarm bells. Instead of diving into our system at a random angle, as you might expect from an interstellar wanderer, 3I₄Atlas entered on a path that lay almost perfectly aligned with the ecliptic plane, the thin, flat disk where all of the planets orbit the Sun. The angle of alignment? Within just 5 degrees. That might not sound unusual at first, but the probability of such a match happening by accident is vanishingly small. Interstellar objects should come from anywhere, from all directions in 3-dimensional space. For one to slip into our system on a path so neatly in line with the orbits of our planets is like throwing a dart across a football field and landing it on the edge of a coin. But the strangeness didn't stop there. As orbital simulations were run forward, another shocking detail emerged. On its journey, 3I₄Atlas would pass remarkably close to not 1, not 2, but 3 major planets: Mars, Venus, and Jupiter. Think about how unlikely this is. Space is vast. Planetary orbits are wide apart. The odds of a random interstellar body threading its way through the solar system in such a way that it intersects with multiple planets are infinitesimal. Yet 3I₄Atlas seemed to be on a course that did exactly that. First, a near approach to Mars, the red planet, humanity's next frontier. Then a pass by Venus, Earth's closest neighbor. And later, an encounter with the giant Jupiter, the king of the planets, whose immense gravity shapes the architecture of the solar system. For some astronomers, this sequence raised unsettling possibilities. Could it really be a coincidence, or was this path chosen, designed? If 3I/ATLAS were some kind of craft or probe, its trajectory looked eerily like a planned tour, a path that maximized planetary encounters. Even those committed to natural explanations admitted the alignment was strange. Normally, interstellar comets are one-time visitors that barrel through space on erratic paths, indifferent to the layout of the planets. But 3I/ATLAS was behaving differently. Almost as if it were aware of the solar system it was entering, this improbable orbit only deepened the mystery. A plume pointing in the wrong direction was one thing, unusual chemistry was another. But now, the very course of the object itself looked suspicious. Was it a coincidence beyond comprehension? Or was there intention hidden in the math of its trajectory? One thing was certain: the more astronomers studied 3I/ATLAS, the harder it became to explain as just another rock from deep space. As the days turned into weeks, astronomers began to notice something even more disturbing about 3I/ATLAS. It wasn't just its plume, or its bizarre chemistry, or even its improbable trajectory. It was the way the object was moving. Careful astrometric tracking revealed that 3I/ATLAS wasn't following the precise path dictated by gravity alone. Instead, it was experiencing an extra push, a tiny but measurable force that was steadily accelerating the object beyond what gravity and inertia could account for. The numbers were precise. The extra acceleration measured at roughly 4 × 10 to the -7 meters per second squared. That might sound small, almost negligible, about the weight of a feather pressing against your hand. But in the vacuum of space, acting on an object for weeks and months, even such a faint force adds up to enormous changes in trajectory. Now, comets are known to sometimes show what's called non-gravitational acceleration, caused by jets of gas erupting from their surfaces. But those outgassing events are chaotic and unpredictable. One jet might flare on one side of the nucleus, then fade. Another might erupt from a different location, sending the comet wobbling in new directions. The effect is irregular, messy, and inconsistent. I/ATLAS, however, was different. Its acceleration was steady. The direction of that push was not random. It was always aligned perfectly with the plume. The same plume that pointed back toward the sun, cutting a narrow line of exhaust through space. This was not chaos. This was control. To scientists, the implications were chilling. A natural comet should not accelerate this way with such stability. The physics didn't fit. The only things we know of that produce steady directional thrust are engines, machines built to control motion. Could 3I/ATLAS really be demonstrating propulsion? Was this not a comet at all, but something designed to maneuver, to adjust its path with precision? For many, the comparison was impossible to ignore. The plume looked less like dust or gas, and more like the exhaust of an ion thruster, the kind of technology humanity itself has experimented with in deep space probes. And the numbers matched. The gentle but steady acceleration was exactly the kind of profile you'd expect from an ion drive. Small in the moment, but relentless over time. At this point, the mystery of 3I/ATLAS had escalated beyond curiosity. Its plume was wrong. Its chemistry was alien. Its orbit was improbable. And now its very motion suggested it might be under power. Nature does many strange things. But nature doesn't hold a steady course against the sun with a clean, consistent thrust. That's the behavior of a machine. The question was unavoidable. Had humanity just witnessed the first undeniable evidence of interstellar technology? The deeper astronomers looked into the behavior of 3I/ATLAS, the more they were struck by one inescapable comparison. Its plume, narrow, steady, and perfectly aligned with its acceleration, looked nothing like the diffuse dust tails of natural comets. Instead, it bore a startling resemblance to something humans themselves had only recently begun to experiment with: the ion thruster. Ion propulsion works very differently from the fiery rockets that launch spacecraft from Earth. Instead of explosive chemical reactions, An ion drive generates thrust by accelerating charged particles, usually xenon gas, through an electric field and ejecting them in a narrow, collimated stream. The result is not a violent push, but a gentle, steady force, one so weak that you could hold your hand in front of it without feeling a breeze. Yet in the vacuum of space, applied constantly over weeks and months, that feather-light thrust builds speed in ways that chemical rockets never could. And here was 3I₄ATLAS, behaving in exactly that way. Its extra acceleration was faint, but consistent. It always pointed in the same direction as the plume. And most telling of all, the plume itself was sharply defined, not spreading out chaotically like cometary gas, but forming a tight beam, the hallmark of an engineered exhaust. For planetary scientists, the similarities were chilling. The numbers didn't just line up vaguely, they matched almost perfectly the thrust-to-mass ratios expected of known ion drives. It was as if the object were using a technology humanity already understood, only on a scale and efficiency far beyond anything we had yet built. This comparison raised the most profound of questions. Was 3I₄ATLAS not a natural interstellar visitor at all, but a controlled craft, one capable of adjusting its path through deliberate propulsion? Was its improbable trajectory through the solar system not a coincidence, but the result of careful navigation, a plotted course designed to intersect with planets along the way? If true, it would mean that for the first time in history, humanity was not merely observing a rock from another star. We were watching technology, a machine from the depths of interstellar space. For some researchers, the implications were staggering. Either we had grossly misunderstood the physics of comets, or we were witnessing something artificial. And given the evidence, the plume, the chemistry, the improbable orbit, and now the acceleration, the artificial explanation was becoming harder to dismiss. It was as if the cosmos had just whispered, "You are not alone." As the anomalies of 3I₄ATLAS mounted, the astronomical community found itself at a crossroads between two radically different explanations. On one side were the conservative scientists, grounded in centuries of experience studying comets. Their argument was simple. Maybe this object was unusual, but it was still natural. The presence of supervolatile ices, primarily carbon dioxide, offered a plausible explanation. CO₂ can sublimate, turn directly from solid to gas, even far from the sun, producing jets of material. If these jets were concentrated in specific areas of the nucleus, perhaps due to rotation or surface irregularities, they could conceivably account for the sunward plume and the measured acceleration. In this view, 3I₄ATLAS was just a comet behaving in a highly unusual way, an outlier but still governed by natural physics. Yet the opposing camp, led by figures like Harvard astrophysicist Avi Loeb, proposed a far more provocative interpretation. Loeb suggested that the precise alignment of the plume, combined with the steady non-gravitational acceleration, could indicate artificial propulsion. In other words, the object might not be a comet at all, but a probe from another star system, intentionally braking or maneuvering as it passed through our solar system. This debate immediately brought to mind the famous case of Oumuamua, the first confirmed interstellar object in 2017. Like 3I₄ATLAS, Oumuamua displayed subtle accelerations that couldn't be fully explained by outgassing or radiation pressure alone. While most astronomers leaned toward natural explanations, a small but vocal group speculated about artificial origins. That discussion had shaken the community and forced astronomers to re-examine long-held assumptions about interstellar visitors. With 3I₄ATLAS, the stakes were higher. The plume's direction, the chemistry dominated by CO₂, the nickel signature, the improbable trajectory, and the consistent sunward acceleration all combined to make the artificial hypothesis harder to ignore. Unlike Oumuamua, this object also had direct visual evidence of its unusual plume, reinforcing the possibility that something more than natural processes was at play. Yet even for proponents of the artificial theory, caution was necessary. Nature is capable of extraordinary surprises. Perhaps there was a mechanism for sunward jets we hadn't discovered yet. Or maybe the nucleus contained pockets of volatile material perfectly, positioned to mimic engineered thrust. The tension between these two views, natural versus artificial, is what makes 3IATLAS so compelling. Each new observation challenges assumptions and forces scientists to ask uncomfortable questions. Could we be seeing technology from another civilization? Or is this just a reminder of how little we truly understand about interstellar objects? Regardless of the answer, one fact was clear. 3IATLAS had reignited a debate that extended far beyond comet science. It was a test of imagination, physics, and humility, reminding humanity that the universe may hold objects and phenomena far stranger than we ever anticipated. To understand the mystery of 3IATLAS, astronomers looked back at the history of interstellar visitors. Each one told a story, and each shaped the lens through which scientists now viewed this new object. The first confirmed interstellar object, Oumuamua, appeared in 2017. Its discovery electrified the scientific world, not just because it came from another star, but because of the strange behavior it exhibited. Oumuamua was elongated, tumbling end over end, and moving faster than anything bound to the sun. Most intriguingly, it accelerated slightly but consistently as it left the inner solar system, an effect that defied standard gravitational modeling. There was no visible tail, no detectable outgassing, and no clear explanation. Some scientists speculated it could be a fragment of ice or an asteroid from another system, while others, like Avi Loeb, suggested it could be a thin, sail-like object, possibly artificial. Oumuamua became a touchstone for what might be possible, a warning that interstellar visitors don't always follow the rule. Then, in 2019, Borisov arrived. Unlike Oumuamua, Borisov behaved like a classic comet. It sprouted a textbook tail, outgassed water and cyanide, and followed predictable physical laws. For astronomers, Borisov was reassuring. Interstellar objects could be both strange and familiar. The case of Borisov provided a baseline. Interstellar objects could be messy, icy travelers like the comets we knew, moving along their solar-bound trajectories without mystery. And now, in 2025, came 3IATLAS, challenging every expectation. This object was a hybrid of sorts. It had a visible tail, like a comet, yet that tail defied cometary physics. It pointed toward the sun, held its shape for weeks, and correlated with a non-gravitational acceleration. Its chemistry was alien, with a CO2 to H2O ratio 8 times higher than typical comets, plus the unusual presence of nickel without iron. The trajectory was improbable, threading past 3 planets with almost surgical precision. The parallels were striking. Oumuamua forced scientists to confront the unknown. Borisov reminded them of the familiar, and 3IATLAS blurred the line between natural and engineered. Each interstellar visitor added a layer of complexity, showing that the cosmos doesn't follow human expectations, and that interstellar objects may come in forms we have yet to imagine. For planetary scientists, these historical cases aren't just academic footnotes. They shape how we design observatories, how we model trajectories, and how seriously we consider the possibility of artificial objects. 3IATLAS isn't an isolated curiosity. It is part of a continuum, a growing catalog that demands new thinking and sharpens the tools needed to track the truly strange. In a sense, 3IATLAS is standing on the shoulders of its predecessors, but it also raises a new level of urgency. The universe may be teeming with interstellar visitors, and each one could challenge our understanding of physics, chemistry, and perhaps even technology itself. As 3IATLAS hurdles through the inner solar system, astronomers are now focusing on a moment of profound significance. October 30th, 2025, its perihelion passage. This is the point in its orbit where it comes closest to the Sun, reaching its maximum speed and experiencing the strongest solar gravitational forces. But perihelion carries an added complication. From Earth's vantage point, the object will pass directly behind the Sun, entering what is known as a solar conjunction. During this period, no telescope on Earth can see it. The sun's glare overwhelms all optical instruments. Radar signals are drowned out by solar plasma, and even near-Earth orbiting observatories lose the ability to track the object. For weeks, 3I₃ will effectively vanish, hidden behind the solar disk, creating a blind spot in one of the most critical windows of its journey. Why does this matter so much? Because if 3I₃ is behaving like a natural comet, this period coincides with the peak of solar heating. Any sublimation of volatile ices, carbon dioxide, water, or even exotic supervolatiles would be at its maximum intensity, producing jets or outbursts that could alter the tail, the brightness, or even the trajectory. But if the plume is a sign of controlled propulsion, this is the ideal moment for a maneuver. A well-timed burn during perihelion could adjust its orbit subtly yet significantly, taking advantage of the Oberth effect, where propulsion at the point of highest speed produces maximal change in velocity. Astronomers are uneasy because there's no way to confirm what's happening in real time. Any sudden acceleration, directional change, or alteration in the sunward plume would go unseen until the object emerges from behind the sun weeks later. Every subtle anomaly observed before perihelion, the plume's stability, the non-gravitational acceleration, the unusual chemistry, now carries heightened stakes because it may be part of a critical phase where the object's behavior is at its most decisive. For planetary defense teams and dynamicists, this is a tense moment. They are preparing for every eventuality, modeling potential paths, simulating how minor forces could magnify during perihelion, and tracking the pre-conjunction acceleration data with unprecedented precision. The goal is simple. When 3I₃ reappears, any deviation from predicted motion, any change in the tail's morphology, could provide clues about its true nature. In short, October 30th is more than just a date on the calendar. It is the ultimate test. Nature could reveal an extreme outgassing event, or the object could perform a maneuver that challenges all natural explanations. For weeks, humanity will watch and wait, suspended in a combination of wonder, uncertainty, and apprehension, knowing that what happens behind the sun may rewrite our understanding of interstellar visitors forever. 3IATLAS is a mystery unlike any interstellar visitor before it. Its sunward plume, unusual chemistry, and precise trajectory defy expectations and challenge our understanding of comets and natural objects. Perihelion behind the sun adds suspense, as any decisive activity will go unseen until it re-emerges. Whether natural or extraordinary, 3I₃ reminds us that the universe is unpredictable and full of surprises. Each new interstellar object expands our knowledge, sharpens our tools, and fuels curiosity. When it reappears, it may reveal answers, or raise even more profound questions about the cosmos. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.